So let's go to number 25. I think if you don't understand this problem, this question could be a little bit hard, even though it's not necessarily a difficult question. So let's look at this together. So it's like it's a wheel, right? So like they spin it, and then basically like usually what happens is that like for this one, there's a little clicky thing that's like it will like land in the like a little area, like either a 9 or 16 or whatever. Or sometimes they do it in like a marble. They roll a marble and see where it ends up, kind of thing. So, but the important thing is not that how the game works, but the fact that there is a $5 bet. Meaning that if you don't win anything, you're basically losing money. Okay, that's something that you need to remember. And there are 16 outcomes, right? All right. So then it wants you to find expected value. So like, what is the long run payoff when you have to bet $5 and then your payoff is like the table, right? So let's look at A, which is the green. So first of all, I need to find out how many green spaces there are. So 1, 2, 3, 4, 5, 6, 7. So there are 7 spaces out of 16. So that is my probability of winning, right? And it says the payoff is 10, but well, you're not really earning 10. You're only earning 5 because you already paid $5 to be on this game, right? And then there are 9 out of 16 times that you are just going to lose. Right? You are not going to earn anything, so you're losing money. So that's how you find expected value, okay? So if you look at it in the table, because we did table x and p of x, and then we basically multiply the two and then add them together, right? So x is basically green, and this is not green. And so 7, oh, sorry. X would be how much money you get it, right? So x would be, you're getting $5 because you got the green, and you're losing $5 because you didn't get the green. So then you multiply these two and then add them this way. So it's the same as what I wrote up there. So let's find that out. So it's 2.1875 for the first one, and then minus 2.8125. So when you add them together, you can tell that it's going to give you a negative number of negative, hello pen. So what this means is that on average, you're going to lose 62 cents, 63 cents. So expected value for green is minus 0.625. Okay? So let's try B, which is even and red. And there is a specific table for that. So the payoff is $25. So that means I need to find how many are even and how many are red at the same time. 1, 2, 3. So there are 3 out of 16 that will give you 25 minus 5, plus the rest of it, which is 13 out of 16, that will give me 0 minus 5. So when you calculate this, it's 3.75 plus negative 4.0625. So my expected value is negative 0.3125. So actually, you're losing less money than the first one. So if you have to bet your money, I would say bet on the even and red instead of green. Let's look at C. All right, odd number, which is a $7 payoff, and then let's count how many odd there are. So don't mind the, what's it called, the color. I just count odd. 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 out of 16, that will give me $2. And then 8 out of 16, that will make me lose $5. Okay? So this is 1, right? Because half times 2. And then negative 2.5, because half times negative 5, so negative 1.5. So you can see how it actually loses more money than anything else. You're on average losing that much money. 1 or 16. So this one, 1 or 16, obviously you can't land on both 1 and 16, even though or in mathematical term means both too as well. So there is only 1 out of 16. So that will give me payoff of that. And there's another 1 out of 16 to get 16. And then my payoff will be that. And then the rest of it would be 15 out of, 14 out of 16. Let's think about this. I think we should actually approach this question as a 2 different way. So 1 would be that I get 1 as my outcome and then lose the $5. So let's calculate what that is first. So when you calculate this, it's actually negative 1.875. And I think that's the answer because it doesn't matter even if you do. So 1 or 16 means like you don't really care if your outcome is 1 or outcome is 16. But your expected value for both of them will be the same because there is only 1 for each one of them. So I think the answer is negative 1.875. Let me know if my answer is not correct, but I think that's it. Yeah. E, last one. That's just 1, right? So then it's also negative 1 point because that's the same as 16. So that means D must be the different answer. Let me think about that a little bit more. But I think unless D means that you are betting on both of them, right? Like, if I think of D as something like I put money on both 1 and 16, okay? So then there are 2 times that I'll win this, right? And then there are 14 times that I'll lose. So unless it's like this, I don't understand how the problem of D and E is different. So if you do it, yeah, but it's still the same probability. So same expected value. So yeah, I think that should be the answer. So let's go to 26. In a recent poll, 62% of Americans said that they had donated their time volunteering for a charity in the past year. If a random sample of 10 Americans is selected, I guess I have a problem spelling Americans because this is not the first time I typo. My typo is like that. All right, exactly 6 people. So this one would be easiest if you use a calculator, the binom, CDF, and PDF, things like that. So I never taught you binom PDF. I only taught you binom CDF. So CDF stands for cumulative. And I think PDF is just like a probability distribution. So whenever it says exactly, you can actually use binom PDF. So what you do is that you go to second vars. And then the trials in this case would be 10 because there are 10 Americans. P is 0.6, oh my goodness, 62. 10, 62. The X value that I'm interested in is 6. So when you do all that, it gives me 0.24872. Okay? At least 5 people means that I want greater than equal to 5. So another way to write this is 1 minus probability of x less than 5, right? So what this can be written as binomial CDF, because binomial CDF always starts from 0 to that number. So it's like at most. So I'm going to do binomial CDF, and then trials 10 again, 0.62 as a probability, x value 5. And then I do 1 minus, actually, I need to do 4, right? Binomial CDF 4 because it's people. So 1 minus that. So like I said, binomial CDF should be 10.062 and 4 because at most 4 people. So this gives me 0.86524. Okay. So I did 1 minus that already. So that's why I got this. C. Let's do C. At most 3 people. So this one is just binomial CDF. Okay. So 10, 0.62, 3. That's what all you need to do. 3. So I get 0.04133. More than 8 people donating, so that's the last one. So this one is more than 8. Okay, so I can write it as 1 minus less than 8. So this one, actually you need to use binomial CDF where the last number is 8. So let's do that. Binomial CDF 10.62 and 8. And 1 minus that number is 0.0598. So that's it. So you can see that how binomial CDF is super useful whenever they have a question like this. Exactly, at least, at most, more than. But you do need to know when to use binomial CDF. So CDF includes 0 to that number that you are specifying in the function. So 4 means you want to look for P of 0 plus P of 1 plus P of 2 and P of 3 plus P of 4. That's what it means. Okay, so when you know exactly what binomial CDF means, you can use it and it will just cut your time to calculate all the probability. Okay, and that's it.